And here is a video that I'm making to go over how you can start putting data into Google Sheets and manipulating it to do different sorts of computations, including making graphs. You're going to be looking at two sets of data. One, tree species with their DBH and height, and also the salary of different professions over 50 years of data, 40 or 4 decades, 5 data points. So let's go to this data table here that I'm going to just show you a few things that you can start to do when it comes to good and bad uses of data. So I have 7 different people with the first name starting with S, and I collected some data with them. Now, one thing that you want to always have is a sort of general preview or overview that usually a row and a column have different meanings. A column is always going to be one set of data for a variable, and a row is going to generally be for one individual thing. So this is Sean. This is Sean's height, Sean's age, Sean's time in the mile, and whether or not Sean is left or right-handedness. So let's go to height and look at what's good and bad about this data. First thing that I noticed that's bad is not all of the data just contains numbers. So notice Sean has a height of 78 centimeters. In Google Sheets, we can only record things as numerical values, which is why in parentheses right here, I have height in centimeters. So I'm going to get rid of this, and I'm going to get rid of 145. Now, there's about 2.54 centimeters in every inch, so I actually feel pretty good about these 5 values here. Seb has a height of 1.65. I don't believe that, so probably this data was recorded as meters. So I'm just going to put this now in as 165. And then notice up here, a height of 78 would be really, really short. That's like 2 feet. Probably not believable. So I'm going to take this and make it a centimeters value. To do that, I'm going to show you how to do math. You always start off with equals. So I pressed equals, and then I'm going to type 78, and then I'm going to press Shift 8, which is going to show me the star, and I'm going to multiply that by 2.54. And lo and behold, I get 198. Let's go over and correct this. The only issue I see is 21 years, so I'm going to make this 21. I'm going to go to handedness. I've seen some people write right and left, left and right, so I just need to go and correct this to be left and right. Hopefully I'm just showing you right now that you need to be super consistent with your variables. This is where I see some issues. I need miles or minute-mile time in minutes and seconds. So I need to have some data points that look like these right here. So I'm going to retype this as 821, 5.3, so that would be 518. A third of a minute is 18 seconds. And then 360, which hopefully, 360 divided by 60 would just be 600. Awesome. This data is now correct. So what are some computations that you can do in Google Sheets? One can be finding the average. So to do that, you're going to go into an empty value, and you're going to press equals again. Google Sheets wants me to do sum, but I'm going to type in the word average. You're going to be looking for this word. It's going to give you a left parentheses, and then you're going to click and drag. You're going to do a right parentheses, and then you're going to press enter. The average height of someone in this group of people is 19.14. Now, if I want to find the average height, I can just simply click on this box, find my blue arrow, and click over, and lo and behold, I just found the average of this row of data, 169.017. What else can I find? Well, that's going to be average. we can also find whether or not we have a range. So I'm going to find the range of the data. Range is usually difference between the maximum and the minimum. So to do that, I'm going to type in equals. You always type in equals when you want to find some sort of mathematical property of a set of data. I'm going to type in the word max, maximum value in a numerical data set. I'm going to highlight all of my data, and then I'm going to subtract from that min, and then I'm going to highlight the same exact data. So B2 to B8 refers to B2, B8. Press enter, and lo and behold, there's a difference of 17 centimeters between my, or 53 centimeters between my people. I'm going to go here, range of 4, which is a little bit easier. 21 minus 17 is 4. So those are two data points that we can do, average and range. Let's go to making a graph. So maybe I'm curious if height and age is a related set of variables. To do that, I'm going to go to height and just click and drag until I go down to C8. So I have all of my height and age data. I'm going to go to insert. I'm going to go to insert a chart. Now, this is showing me some data related to height and age, but it's showing me a bar graph. I think I want to see something that shows a scatter plot. So over here, I'm going to go to setup. I'm going to press chart. And notice it shows me options. I have a column chart. I want a scatter chart. And now I have something that exists on an X and Y axis that shows me some nice data points. Looks like there might be a relationship, but it's kind of weak. How can I test that? I'm going to double click. Here's my setup. And I'm going to go over to customize. I'm going to go over and click on series. And then I'm going to go and press insert trend line. This is showing me a line of best fit. And it's generally showing me that generally taller people are older, although I see an outlier right here. I can get a mathematical approximation of how strong this relationship is by scrolling down and pressing show R squared. And that's right there. Now R squared is a value that exists between 0 and 100 for positive lines, or 0 and 1. And this is showing me 0.268. What this means is about 27% or 0.27% of someone's age is explained by their height, which means it's not a very good relationship. Now I can go in to my customize. I'm going to press series, and I can change this type of trend line by going right underneath trend line and pressing linear. I could make it exponential. Notice it changes the R squared not one bit. I could make it polynomial. It makes it better by a thousandth of a percent. Not really good. I could make it logarithmic. It actually gets worse. You're usually going to pick the relationship that is best for your trend line. And it's going to be the one that sort of makes the most sense based on how the dots go, and it's going to be the one that's reflected in the data the best. So that's how you make a basic scatter plot and add a trend line with an R squared value. So let's see if I can graph another set of data. I have years and people, so I'm going to highlight this data, years and people. I'm going to go to insert chart, right here. Nope, I want chart. And it gives me this. I'm going to go up to setup and make it a scatter plot. And it still doesn't look quite right. And there's a couple of reasons why. A, On my x-axis, I have year and people, and then I have some arbitrary y-axis. Often you will have this issue with your Google Sheets if you aren't following the basic layout I showed you earlier. If you have year and people as rows and not columns, it's going to be hard to get your data correctly formatted to make a graph. So I'm going to quickly go in and make some changes. So this would be 45, 2,000, 14,000. Perfect. I'm going to go to Insert, Chart, and lo and behold, it makes a scatter plot instantly. I'm going to go into Customize, go to Series, I'm going to add a trend line, and I'm going to show R squared. Oh, 85% of the data is explainable between years and people. Now, 3 data points is not a lot of data, but that looks pretty good. I want to see if I can do better. So I'm going to go to Type, and I'm going to make it exponential. Oh, snap. Look at that. 99.9% of the data is explained by an exponential rate of increase. It's nonlinear. So that's where playing around with the R squared sometimes can give you a little bit more information about the context. I'm going to leave these 2 graphs up so you can see them when you're doing your homework here. What else can I teach you? I don't like this graph right now because notice it starts at 0 and the youngest person is 17, so I'm going to show you one more trick. I'm going to go into Customize, and then I'm going to go to Vertical Axis, which is my Y-axis. See where it says min value? I'm going to make that 15. I'm going to make my max value 25. Let's make it 23. I now have a much better relationship that shows that. And again, all I did was go into Customize. I went to Vertical Axis, and then I changed my min and max. So let's take a look at our data. You have a set of data looking at teachers, lawyers, police, and astronauts in terms of employment, how much you make per year between these 4. If I go into my Google Doc, looking at this homework assignment, which I'm going to load right now. It's actually not this one. Biology data and spreadsheet formative. It's not a formative. This is just you guys learning it. So this is not a graded assignment. You're going to be needing to find the average salary of 1916-2000, the change in salaries between 1980s and 2000 that sounds like a range, make a scatter plot, add a line of best fit, and look for the best line for that. Ooh, we have to do one more thing, which is learning how to sort data. So let me go back and show you how to do that. So if I wanted to sort my data, let's say I wanted to sort by this, I want to sort this data by the starting salary, smallest to biggest in 1960. I'm going to highlight my data. I'm going to go to Data, Sort Range, and I'm going to do Advanced Range Options. First thing you should always do when you go to sort data is press Data has header row, then it won't sort row 1. I'm going to then pick 1960. I'm going to sort all of my data by this column. A to Z is always smallest to biggest. So I'm going to press Sort. And now, lo and behold, police, 45, teachers, 51, astronauts, 65, lawyers, 85. I've sorted all of the data based on this range. The only other thing that I can show you is that if you go in your homework to make this scatter plot, so I'm going to go to Insert, Sheets, whoops, did not mean to do that, I'm going to delete that. Insert, Chart, and I have my 4 things already made, excellent, and I press Add Trend Lines to all of my series. when I go up to series right up here, I can go to police and I can do some fun things. Like I'm going to change the police color to purple. I'm going to make it 14. Notice the big purples. And I'm going to make it a triangle. You can then also change the specific type of trend line for that series. And then you scroll up, and then you can change to teachers. And I'm going to make teachers an X. And they're going to be 14. And let's make them red. Or no, let's make them black. There we go. That's one more thing to know. I'm sure that this video is a little bit long, so I would watch it and then attempt the homework. We're going to be practicing this on Monday with some more examples, but this is just meant to be a foot in the door. Get you starting to practice putting data into a spreadsheet, graphing it, and doing some computations with it. This will be a skill that we will learn all year long and practice in many different ways. I'll see you guys soon.